example 3 on the back, based off what we did on the front, would make sense to say radical 7 multiplied by that. Radical 7 over radical 7. So let's go ahead and try it. Well, again, radical denominator, we're going to multiply the top and bottom by that radical. When we do so, that's 3 times radical 7. 3 radical 7. And when we multiply the bottom, you have to be careful. We're multiplying the 4 by radical 7, and we're multiplying the radical 7 by radical 7. So what's 4 times radical 7? And what's radical 7 times radical 7? 7, or radical 49. And what's the square root of 49? Does that get rid of our problem? Having a radical denominator? No. So, when it's just a single radical, you're not adding or subtracting, that's what you're going to multiply. Whatever radical's the denominator, that's what you're multiplying the top and bottom by. When you're adding or subtracting a radical, you can't use this method. There's a different method you have to use. So no, this will not work. There's still a radical in the denominator. Okay? Did not get rid of the radical in the denominator. Okay? So just a radical, that's exactly what you do. Whatever radical in the denominator, multiply the top and bottom by that. When you're adding or subtracting a radical in the denominator, there's a different method. Okay? And that method, or the thing that you have to use, is called a conjugate. So you would multiply the top and bottom by the conjugate of the denominator to get rid of that radical. Okay? Here are some examples of conjugates. X plus 2, x minus 2. That's an example. 3 plus I, 3 minus I. That's an example. 4 minus radical 7 and 4 plus radical 7. Those are all examples of conjugates. What are you noticing about them? Yeah, what do you mean by that? Do the terms change at all? No, that's the only thing that changes. The sign. Yeah, so conjugates, essentially, it's the same terms. You just change the middle sign. It's the same terms, but there's an opposite middle sign. So the sign in between them are opposite. Okay. So one's going to have a plus sign in the middle, one's going to have a minus sign in the middle, but the terms are going to be exactly the same. That's a conjugate. Okay. So now we're going to see what happens and why we need to use the conjugate. So the same denominator from that previous problem, we're going to multiply it by its conjugate. So when we do so, essentially when you have something like this, all we're doing is FOILing. So we're going to take 4, distribute it. What do we get when we do 4 times 4? What's 4 times radical 7? And then negative radical 7 times 4 is just radical 7. And then a negative times a positive is a negative, and a 7 times a 7 is a 49. So that becomes radical 49. Go through and combine your like terms. What do you notice happens when you combine your like terms? What happens to those 4 radical 7s? They cancel out because they're opposites. Okay? So we're left with 16 minus, what's the square root of 49? 7. And what's 16 minus 7? Okay. That's why we need to multiply by the conjugate, because it gets rid of those radicals. So we're left with a number in the denominator. Okay. Questions over that? Now, let's see what happens when we do multiply the top and bottom by the conjugate. So the conjugate's 4 plus radical 7, or the denominator's 4 plus radical 7. The conjugate's going to be what? Once the middle sign's a plus sign, the middle sign's going to turn to a negative for the conjugate. So we would say 4 minus radical 7. So whatever is the bottom, you're also going to multiply in the top. Well, when we multiply the top, what do we have to do with that 3? Come inside, take it. What do we have to do with the 3 in the top? Get my cards out. Do I not have cards for algebra 2? What do I have to do with that top one? Top number. You guys left out. Can't find my algebra 2 card. What do I have to do? Yeah? Distribute it. Yeah, it's like a normal problem. Number on front, you just distribute. 3 times 4 is what? 12. And then 3 times negative radical 7 is? Negative 3 radical 7. And then in the bottom, just like we did up here, you just FOIL. So again, you kind of already know what the answer is going to be, but 4 times 4 we said was 16. And then 4 times negative radical 7, negative 4 radical 7. Radical 7 times 4, 4 radical 7. And then radical 7 times negative radical 7 is negative radical 49. Just like what we did up there, same thing. So again, what happens to those middle terms? They cancel each other out. Fun. So that top part is staying exactly the same. That's staying at 12 minus 3 radical 7. Can we simplify the radical? We can't simplify radical 7, so we just leave it. Okay? But in the bottom, what did we say our outcome ended up being when we had 16 minus radical 49? 9. We know that's 9. Normally we would take the steps, so we already did all that work up there. So we know our outcome is 9. So when you get to this step, you always have to look and see, do we have heart? Is there something that can go into all 3 of those? Yeah. So you're going to divide all 3 values by 3. So 12 divided by 3 is 4. Negative 3 divided by 3 is 1. Keep the radical there. And 9 divided by 3 is 3. Okay? The reason why I like to heart because it excludes the radical. You can't divide the radical. Just stays how it is unless you just simplify it. And then we're done. So whenever you're adding or subtracting your radical in the denominator, you multiply the top and bottom by the conjugate. In other words, those 2 terms stay the same. You just change the middle number to the opposite. That's a big thing. I think it's one of the things we see the most is that middle sign doesn't change. You have to remember, change the middle sign. Okay? You just distribute the top, distribute the bottom, clean everything up, and then your last step, look to simplify, see if you have heart. There's a number that can go into those 3 numbers on the outside of the rack. Questions over there? Alright. We take a look at the next example. We have a radical in the denominator. We need to get rid of it. How are we going to get rid of it? What do we need to multiply the top and bottom by? 1 plus radical 11. Whenever you're adding or subtracting, multiply the top and bottom by the conjugate. Same terms, change the opposite in the middle. So if it's a negative, it's going to become a positive. So whatever you do to the bottom, that's what you are doing to the top. What do we have to do to the 2 on the top? Distribute. So 2 times 1 is 2. And 2 times radical 11 is? And then in the bottom, distribute the 1. 1 times 1 is 1. 1 times radical 11 is just radical 11, that doesn't change. Negative radical 11 times 1 is just negative radical 11. And then negative radical 11 times positive radical 11 is negative radical 121. Clean everything up. Is there anything we can do in the top? Super tempting. But they both have to have a radical 11. They don't, so there's nothing we can do. So just leave it how it is. And then what happens to our radical 11s in the bottom? Well, they're opposites, so we're just left with 1 minus. What's the square root of 121? 11. Good. And that back number is always going to be a perfect square, and you're always going to be able to take the square root of it. So if it ends up not being a perfect square, then go back. Sometimes we add them. So sometimes you might have write 22. So just go back. You should always get a perfect square as this back radical because we multiply the same number. Okay. Clean it up even more. Top saying how it is. There's nothing we can do. But what's 1 minus 11? 10. And our very last step, check and see. Do we have part? Is there a number that can go into all 3? Yeah, we can go into 2, 2, and 10. 2. So 2 divided by 2 is 1. And then negative 10 divided by 2 is negative 5. If you leave it like this, totally fine. That negative, it's okay for that negative to be in the denominator. If that's like for me, or some people like, I don't like that negative being in the denominator. Right? Well, you can simplify it. Whenever you have a negative in the denominator, you change the signs to opposite. So it just becomes negative 1 minus 1 radical 11 all over a positive 5. This is totally fine. Don't have to worry about knowing that. That's even more simple than I purpose. Not too concerned with that. As long as you can get to the box, the purple answer, I'm fine. Questions over that? No? Okay. So for 5, state the conjugates of each of the following. You do not multiply them together, you're just stating what the conjugates are. So look at A. If we have 6x minus 4, the conjugate would be 6x plus 4. Very good. In B, if we have 8 plus 2i, the conjugate would be 8 minus 2i. If you have 5 minus radical 7, the conjugate would be 5 plus radical 7. And lastly, if you have A minus B, very good, the conjugate would be A plus B. And the terms stay exactly how they are. The sign in the middle just changes to the opposite. That would be the conjugate. I'm going to recap. If you have what we did on Monday, you just had a regular old radical, like that. You just multiply the top and bottom by radical 3. Right? If you have what we did today, we are adding or subtracting a radical, you multiply by the conjugate. Right? Simplify it that way. Questions over that?